Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use product and chain rules to differentiate each of these three functions. So let's start with the first function on the left side. So this function is h at x equals x cubed parentheses 3x minus 5 squared. Now this function is made up of two functions being multiplied. The first one is x cubed and then the second one is 3x minus 5 squared. So the first step is to use product rule to differentiate this function. So our first step is, so prime of h at x equals, so we start with the derivative of the first function x cubed and the derivative of that is 3x squared times the second function and then plus the first function, which is x cubed, times the derivative of the second function. Now for the second function, we'll have to use the chain rule to find its derivative. So there is an inner function, 3x minus 5, and the outer function is the exponential function, which has the exponent 2. So we'll first find the derivative of the outer function using the power rule. So we start with 2, so the exponent 2 comes to the front and we get 3x minus 5 and we subtract 1 from the 2 times the derivative of the inner function and that will be 3. So 5 is a constant, so that's why its derivative is 0, so it will go away and the derivative of 3x is just 3. So now we can simplify this expression. So prime of h at x equals, so the first part stays the same, 3x squared times 3x minus 5 squared. And now in the next part, we can multiply 2 by 3. So we get 6. So we get plus 6x cubed and then 3x minus 5. And the exponent is 1, but we don't write 1 as in exponent. Now we can simplify this expression by doing common factoring. So from these two terms here, we can factor out 3x squared. From 3x squared and 6x cubed, we can factor out 3x squared. And from 3x minus 5 squared and 3x minus 5, we can factor out 3x minus 5. So we are left with 3x minus 5 from the first part and then 2x from the second part. Now we can combine like terms in the parentheses. So prime of x equals, so 3x squared times 3x minus 5. And now we can combine like terms in the parentheses. So 3x plus 2x is equal to 5x minus 5. Now we can simplify this expression further by doing common factoring from this last parentheses. So we can factor out a 5. So we get prime of h at x equals 3x squared times 3x minus 5 times 5, and then we are left with x minus 1. Now we can multiply the 3 at the front and this 5 that we just factored out. So we get prime of h at x equals 15x squared times 3x minus 5 times x minus 1. So this should be the final answer for the derivative of the first function. Now we can find the derivative of the second function. Now the second function is also made up of two functions. So the first function is x to the power 4, which is being multiplied to 1 minus 4x squared exponent 3. So we'll have to use product rule to find the derivative. So we'll use the prime notation. So y prime equals, so we start with the derivative of the first term. So the derivative of x to the power 4 will be 4x cubed times the second function, so 1 minus 4x squared exponent 3 plus, now we will write the first function x exponent 4 times the derivative of this second function, and for the derivative of the second function we'll have to use the chain rule because there is an inner function 1 minus 4x squared and the outer function is the exponential function with exponent 3. So for the derivative of the outer function, we'll use the power rule. So we'll get 3 and then 1 minus 4x squared, and we subtract 1 from 3 times the derivative of the inner function, which will be 0 minus 8x. So 1 is a constant, so its derivative is 0, and for 4x squared the derivative will be 8x. Now we can simplify this expression. So we get y prime. So the first part will stay the same, 4x cubed times 1 minus 4x squared cubed. Now in the second part, 0 minus 8x is equal to negative 8x, and we can multiply negative 8 by 3. So we'll get negative 24 and then x exponent 5, because x to the power 4 times x will be x exponent 5, then 1 minus 4x squared exponent 2. Now we can simplify this expression further by doing common factoring. So we get y prime equals, so from 4x cubed and 24x5 we can factor out 4x cubed, and from 1 minus 4x squared cube and 1 minus 4x squared square we can factor out 1 minus 4x squared in parentheses and then squared. And now we can write what's left over from the terms. So from the first part we are left with 1 minus 4x squared, and from the second part we are left with negative 6x squared. Now we can simplify this expression by writing the simplified form of the expression in the last parentheses. So we get y prime equals, so 4x cubed and 1 minus 4x squared exponent 2, and then in the parentheses we get 1, and now we combine the like terms, negative 4x squared and negative 6x squared, so I get negative 10x squared. So this should be the final answer for the derivative of the second function. Now we can find the derivative of the third function, so I'll use a different color. Now this function is in the form of a rational function, and there is an exponent on both the numerator and the denominator. Now the first step is to distribute the exponent to the numerator and the denominator. Now this function can be differentiated either using the quotient rule, or we can use the product and chain rules. So for this problem, since we are using the product and chain rule, so we'll use the second way. So the first step is to rewrite this function by distributing the exponent 4 to the numerator and the denominator separately. Now in order to use the product rule, we'll move the denominator to the numerator, and that will make the exponent negative. So x squared minus 3 exponent 4, and then x squared plus 3 exponent negative 4. So now there is no denominator, so we can use the product rule, and we'll also use the chain rule along the way. So since this function is made up of two functions being multiplied, so we'll have to use the product rule. So we'll use the prime notation. So y prime equals the derivative of the first function. So we'll use the chain rule because this function has an inner function x squared minus 3, and the outer function is the exponential function with exponent 4. So we'll use power rule for the outer function. So it'll be 4 and then x squared minus 3 exponent 4 minus 1 times the derivative of the inner function, which will just be 2x. Because 3 is a constant, so its derivative is 0. Then times the second function x squared plus 3 exponent negative 4. Plus, now the second part of the product rule. So we'll write the first function. So x squared minus 3 exponent 4. Then now we have to use the chain rule. So for the derivative of the outer function, so we'll move the exponent to the front, and then x squared plus 3 exponent negative 4 minus 1. And then we have to find the derivative of the inner function. So the inner function is x squared plus 3. So the derivative is just 2x. Because 3 is a constant, so its derivative is 0. Now we can simplify this expression. So first we'll multiply 4 by 2x, and that will give us 8x. And then x squared minus 3, and the exponent is 3. Now for x squared plus 3, the exponent is negative 4, so we can move it to the denominator, and that will make the exponent positive. And now the second part. So in the second part, we have to multiply negative 4 by 2x, so we get negative, so then 8x, and then x squared minus 3, and then exponent 4 over, now here also we'll move the x squared plus 3 to the denominator because its exponent is negative, so we'll get x squared plus 3 exponent 5, because negative 4 minus 1 is equal to negative 5. Now we can simplify this expression by doing common factoring. So here we can factor out 8x. From the numerator, we can also factor out x squared minus 3 to the power 3 from the numerator, and x squared plus 3 exponent 4 from the denominator. So we get y prime equals, so 8x, and then x squared minus 3 exponent 3 over x squared plus 3 exponent 4. Now we'll write what's left over from these two terms. So from the first term, we are left over with just 1. Because we factored out the 8x, then x squared minus 3 exponent 3, and then x squared plus 3 exponent 4. And then from the second term, we are left with just x squared minus 3 numerator and x square plus 3 from the denominator. Now we can simplify this expression in the parentheses by subtracting the terms, and for that we'll have to find a common denominator. So the common denominator here will be x squared plus 3. So we'll multiply the numerator by x squared plus 3 and the denominator of 1, which is just 1. So we'll multiply that also by x squared plus. So our next step will be, so we can go here, so y prime equals, so first we'll write what we factored out, so 8x times x squared minus 3 cubed over x squared plus 3 exponent 4, and then in the parentheses we'll have x squared plus 3, then minus x squared minus 3, and the common denominator will be x squared plus 3. Now we can simplify this expression, so we can move over here. So now in the next step we can distribute the numerator. So the factor will be the same, so 8x, then x squared minus 3 exponent 3 over x squared plus 3 exponent 4. Now in this parentheses, so we'll distribute the negative sign outside the parentheses in the numerator into the parentheses. So that will change the sign of the terms in the parentheses. So we'll get, so x squared plus 3 will stay the same, and then we'll get negative x squared plus 3 because there's x squared minus 3 in the parentheses over the common denominator, which is x squared plus 3. Now we can combine like terms in the numerator, so the x squared and negative x squared will cancel each other out. So we get y prime equals, now we are left with 3 plus 3 in the numerator, which is 6, and we'll multiply that 6 by 8. So we'll get 48x, then parentheses x squared minus 3 cubed over, now in the denominator we'll multiply x squared plus 3 exponent 4 with x squared plus 3. So we'll get x squared plus 3 exponent 5. So this should be the final answer for the derivative of this third function. So these are the steps you have to keep in mind to find the derivative of these functions. So it's very important to identify which rules to use at which step to find the correct derivative for these types of functions. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.